We will now discuss the solution of a problem from the section Partial Differential Equations. This question is on the method of separation of variables. This question has appeared in the CSIR National Eligibility Test held on 16th February 2022, and it is from the part C. The given question is, let u of x comma y, then solve the partial differential equation PDE, x square into dou square u by dou x dou y plus 3y square u is equal to 0 with u at x comma 0 is equal to e power 1 by x. Which of the following statements are true? Options. We are given 4 options. Option 1, the PDE is not linear. Option 2, u at 1 comma 1 is equal to e square. And option 3, u at 1 comma 1 is equal to e power minus 2. Option 4, the method of separation of variables can be utilized to compute the solution u of x comma y. Right. We have u a function of two real variables x comma y, and we are given a partial differential equation x square del square u by del x del y plus 3y square u is equal to 0 with the boundary condition u at x comma 0 is equal to e power 1 by x. Then we have to decide which of the following statements are true. It is a section C, therefore there can be more than one answer, and we have to spot all the right answers. Right. We now discuss the solution of the problem in detail. We have u is a dependent variable and x comma y are independent variables, and u is a function of u of x comma y. And we are given the partial differential equation x square del square u by del x del y plus 3y square u is equal to 0. It is a partial differential equation, and we now consider the option 1. The partial differential equation is not linear. Is it linear? That's the question. Now, observe that the PDE 1 is linear. Why? Because the dependent variable u and its partial derivatives are occurring in the first degree, and they are not multiplied together. And that is the definition of linearity of partial differential equations. Therefore, the given partial differential equation is linear. So, the option 1 is not true. We continue in the next slide. Consider the fourth option. The method of separation of variables can be utilized to compute the solution u of x comma y. We have that given partial differential equation, which we have named it as the equation 1. Suppose that the solution of 1 is of the form u of x comma y is equal to x of x into y of y, where x and y are functions of x and y alone respectively. That means x of x means x is a function of x alone. Y of y means y of y is a function of y alone. Right. That means we are supposing that the variables can the variables be separated, and can the method of separation of variables will bring the solution of this partial differential equation? That's what we are going to see. Agreed. Agreed. So if this is the case, u del square u by del x del y is equal to x, the derivative of capital X with respect to x once, x prime into y prime. This is del square u by del x del y. Now putting it in the equation 1 back, then we will get x square into x prime into y prime plus 3y square into u is x into y. Now we separate the variables. X square into x prime by x, this is a function of x alone, is equal to minus 3y square capital Y by y prime, which is a function of y alone. Let us say each is equal to k. Agreed. So now first we take this first ratio. X square into x prime by x is equal to k. That will imply x prime by x is equal to k by x square. Yes. Yes. Integrating integral of dx by x is equal to k times integral of 1 by x square dx plus a constant of integration plus ln c1. That implies integral of dx by x is ln x log x to the base e is equal to k times integral of 1 by x square is minus 1 by x, that is minus k by x plus ln c1. Take out the logarithms, we'll get capital X, which is a function of small x alone, is equal to c1 into e power minus k by x. Thus capital X is solved. Let us take the second ratio, minus 3y square into capital Y by y prime is equal to k. This will be equal to y prime by y is equal to minus 3y square by k. Yes. Integrating integral of dy by y is equal to minus 3 by k integral of y square plus ln c2. Integral of dy by y is ln y minus 3 by k integral of y square is y cube by 3 cancels. So we will get ln y is equal to minus y cube by k plus ln c2. Now take out the logarithms again. So capital Y, which is a function of y alone, is equal to c2 into e to the power of minus y cube by k. Thus we obtain capital X and capital Y. That means we are able to find the solution of this one by using the separation of variables. So the option 4 is true. That we will see in the next slide. So we have capital X we got, and which is a function of x alone, small x alone, capital Y, which is a function of small y alone, and therefore the general solution of the given partial differential equation 1 is uxy is equal to x of x multiplied by y of y, that is equal to x of x is c1 e to the power of minus k by x multiplied by c2 e to the power of minus y cube by k. That is c1 into c2 is a c, which is another arbitrary constant, times e to the power of minus k by x into e to the power of minus y cube by k. So we are able to find the solution. Now let us take the boundary condition. U of x comma 0 is given as e to the power of 1 by x. So put in this solution y is equal to 0. So u of x comma 0 is equal to c into e to the power of minus k by x into e to the power of minus 0, that is e power 0 is 1. So, but that is equal to e to the power of 1 by x. That means c e to the power of minus k by x is equal to e to the power of 1 by x. Comparing, we get c is equal to 1 and k minus k is equal to 1, that is k is equal to minus 1. So we got c is equal to 1, k is equal to minus 1. Substituting back in the solution, we get u of x comma y is equal to e to the power of c is 1 e to the power of minus k, k is minus 1, minus k is plus 1, e to the power of 1 by x into e to the power of y cube. That means e to the power of 1 by x multiplied by e to the power of y cube, that is e to the power of 1 by x plus y cube. That is the solution. So this means we are able to find the solution of the given differential equation by the method of separation of variables. So the option 4 is true. Correct. Now let's see the option 2, that is u at 1 comma 1 is e square. Option 3, u at 1 comma 1 is e power minus 2. So we have u of x comma y, and in this put x is equal to 1 and y is equal to 1. So we will get u of 1 comma 1 is equal to e to the power of 1 by 1 is 1 plus y cube is 1 cube, that is 1. So e to the power of 1 plus 1, that is equal to e square. That means the option 2 is true and option 3 will be false. Yes. Therefore, the option 2 is true because it is e square, and the option 3 is not true because u of 1 comma 1 is given to be e to the power of minus 2, but the answer is e square. That's there in the option 2. And thus the option 2 is true and option 3 is not true. So let us consolidate. And what we have seen is option 1 is not true, option 3 is not true, and option 2 is true, and option 4 is true. So the answer to this question is option 2 and option 4. So that is the detailed discussion of the solution of the problem from the partial differential equations, and it is based on the concept of the method of separation of variables. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.